Hello dear student, the topic which we are doing today, this one is known as work, energy and the power. Okay, this one is a class 9th chapter. Now in case of this one, the first one, that one is said to be, you have to define that what is work done. Work is said to be done. So there are, it's a formula which is there and it says that work, it is equal to force into distance. So whenever we are applying any of a force and there is a displacement in this one, so we say this one as the work done. So we can say that work is said to be done if on applying a force on an object it displaces from its position in the direction of the force. So if you are applying a force on any of a object and the object it is moving in the direction, in any of a direction, so we say this one as the net value of the work is done on it. Okay, so work is equal to force applied into net amount of the distance or the displacement. Work is equal to force into displacement. Now scientific concept of the work done, if we are considering or we are dealing with the work done, so what are the scientific conception of the work done? From a point of the science, there are two conditions which should be satisfied. Okay, you should satisfy two conditions by which you can say that a work you are doing. So whenever you are doing a work, you should have a force of, you should apply a force in any of a object and there should be any of a displacement. It means that work is equal to force into displacement. Okay, if any one of the above condition does not exist, if either the force is not there, value of the force is 0, value of the displacement is 0. If the value of the force is 0 or the value of the displacement is 0, so we can say that the net amount of the work done, it is always equivalent to 0. In this way, C has exerted you can say that the force, if you are applying a force on a trolley and it is displacing from the any of a position, so we can say that work is equal to, work is to be done, work is equal to force into any of a force into distance or the displacement. After this, work done by a constant force, work done by a force on an object is equal to the value, magnitude of the force multiplied by the distance moved in the direction of the force. After that, we have the next one, the work done is equal to force into distance. Now if we have the net value of work done, so we can say that the work is equal to force into the value of the distance. So let us think that we are having any of object, and in this object you are applying the net value of the force and it is moving to this direction, so we can say that net value it is equal to force into any of a distance, that one is given as S. So work is equal to force into distance. So here distance is the initial position and the final position. The distance between these 2 points, it is said to be the initial position and the final position. Now it comes a very important thing, work is equal to force into distance. So if you are talking about the unit of work done, what is the SI unit of the work done? So the force, it is said to be Newton and the distance, it is said to be meter. So 1 Newton into 1 meter, it is said to be 1 joule. Hope so this one is very clear to you. So if the force is equal to 1 Newton, S is equal to 1 meter, then the work done by the force, it is equal to 1 Newton meter. The SI unit of the work is Newton meter and this is also called joule. So 1 Newton meter, it is said to be a joule. So 1 joule is the amount of work done on an object when a force of 1 Newton displaces a object by 1 meter. Okay, on the when we are when you are reading about this one, so we can say that the work done, it is further divided into 3 types. One is said to be the positive work done, one is said to be the negative work done, and one is said to be the zero work done. So a very simple thing, if you are applying a force in this direction and the displacement is also is in this direction, we say this one as the positive work done. If you are applying a force is in this direction and the displacement is in the opposite direction, we say this one as the negative work done. So example of the negative work done, we can say that, let us think that we are having this one, the force applied, you are applying a force in the upward direction but the displacement it is in the downward direction, so we can say that this one is said to be the negative work done. Now the last one, that one is said to be the zero work done if there is no displacement. So when the force and the displacement are in the same direction and the angle between the force and the displacement is 0, the work done will be positive and the work done, there is a positive work is done by the forces. After this, if we have the next one, a boy pulls a object towards himself. So you can say that the work is equal to force into that one is the distance. Work is equal to force into distance. So when the force and displacement are in the opposite direction and the angle is 180 degree, so we can say this one as the negative work done. The frictional force act in the direction opposite to the direction of the displacement, so the work done by the friction will be negative. So we can say that the work done, that one will be equal to minus F into S. When the force and the displacement are perpendicular to each other, a very good example. If the force and the displacement are perpendicular to each other, at that time the net value of the work done, that one is also equivalent to 0. So let us see that a person is, it is apply a force is there, and a person, you are applying a force in this direction, and displacement is over here, and the value it is given as the 90 degrees. So work is so formula over here, work is equal to F into S into cos theta. So at that time F into S into cos 90, so the net value will be equivalent to 0. Okay, so when the force and the displacement are in the perpendicular direction and the angle between the force and the displacement will be equal to 90 degrees, then net work that is equal to 0. Example, the coolie carrying a load on his head. In this case, gravitational force is acting downward direction, weight of the load, and displacement is in the horizontal direction. That is, the force and the displacement are perpendicular to each other. In this case, net value of the work done, that one is equal to 0. After this, we have the next one. That one is said to be the energy. It is the ability to do work. It is always essential for performing any mechanical work. An object having the capability to do work is said to possess energy. The object which does the work loses energy, and the object on which the work is done gains energy. The energy of an object is measured in terms of its capacity of doing work. Okay, and the SI unit of energy is same as that of the work, so we can say this one as the joule. So the SI unit of energy, so we can say that energy, it is equivalent to SI unit of energy, it is equivalent to net value, that one will be equal to work done. So we will say this one as the 1 joule. Okay, so 1 joule, that one is the amount of the energy. SI unit of the energy is same that of the work done, so we can say this one as the 1 joule. Okay, after that we have the next one. It is the ability to do work, and it is the ability to work, it is always essential for performing any mechanical work. An object having the capability to do work is said to possess energy. It is having the energy. The object which does the work and loses energy, and the object on which the work is done, it gains energy. So one, it loses the energy, one, it gains the energy. The energy of the object is measured in the terms of its capacity of doing work. Okay, so whenever we are dealing with any type of the energy, if we are saying that it is energy, so what actually is the energy? Energy is the capacity to do work. Okay, so whenever you are doing any of a work, we say this one as the capacity. So the energy of the energy of an object is measured in terms of the capacity. The SI unit of the energy, that is known as joule. 1 joule of energy is required to do one joule of energy is required to do 1 joule of work. The larger unit of energy is kilojoule. So 1 kilojoule, it is equivalent to 10 raised to the power 3 joule. Okay, so we can say that 1 kilojoule, that one will be equivalent to 10 raised to the power 3 joule. Work done against a force is therefore stored as the energy. When a fast moving cricket ball hits a stationary wicket, the wicket is thrown away. When a raised hammer falls on a nail placed on a piece of a wood, it drives the nail into the wood. Sun is the biggest natural source of the energy to us. We can also get energy from the nuclei of the atom and the interior of the earth and the tides in the oceans. Dear student, after this we have the next one. That one is there are several forms of the energy. So for forms of the energy, it means that let us think that you are having a ball and you are throwing the ball, so there is a velocity in that one, and that velocity is the kinetic energy. If you are having any of a object and you are displacing that object to the upward direction, that one is the potential energy. So the energy which is possessed by the object due to the motion, whenever there is any of a relative motion or there is any of a speed, we say this one as the kinetic energy, and the SI unit is said to be joule. The kinetic energy energy of a body moving with a certain velocity is equal to the work done on it to make it acquire that velocity. Whenever you are applying any of a force, and due to the force any of a object it is moving, so let us think that you are having any of a ball and the object it is moving, so we say this one as the velocity. The kinetic energy of an object increases with its speed. If the speed increases, the value of the kinetic energy it is also increases. Due to the kinetic energy, a bullet fired from a gun fires a target, pierces a target. So a simple thing, if you are having any of a gun, and you have you have fired a bullet from there, then definitely it will go. If you have any of a target is there, it will penetrate that target, and so there is a velocity in that one, and this velocity is definitely due to a kinetic energy. A moving hammer, if you have a hammer and it drives a nail into the wood, so in case of the wood you are having any of a nail, and you are hitting that thing due to the motion. Now it has the kinetic energy or the ability to do work. Running horse has the kinetic energy. If any of a thing it is moving, it has the kinetic energy. The flowing river, it has the kinetic energy. So in case of this one, the value of the kinetic energy, it is equivalent to half mv square. So the value of the kinetic energy, that one will be equal to half mv square. Such important result which can be derived from the formula of the kinetic energy, it is given as the value of the kinetic energy, it is given as half mv square. If the value of the kinetic energy, it is given as the half mv square if the mass of the object is doubled. Okay, so if the mass of the object is doubled and its kinetic energy is also get double, definitely in case of the mass, so you can write down this one as 1 by 2. In case of the mass, you can write down this one as 2m, and this one is v square. So what is the relative change? So this one will be equal to how much? So you can say that it is half mv square, and this one is 2 into half mv square, so it becomes the twice of this one. If the mass of the object is half and the kinetic energy is also half, okay, so mass is half, the kinetic energy it also get half. If the speed of the object is double, its kinetic energy become 4 times. So if you have this one as the kinetic energy, so this one will be equal to half m, and the value of the speed is 2v square. So if you will see this one, so in case of this one, what is 2v square? So 2 to the 4, it will become how much? It will become 4 times. Similarly, if the speed of the object is half, the kinetic energy become 1/4. The heavy object moving with the high speed have more kinetic energy than a small object moving with the same energy. A very simple thing, it depends upon the mass. A heavy object has more mass, so it has the greater value of the kinetic energy, and the another any of object having the less mass, it has the less value of the kinetic energy. After this, we have the next one. That one is said to be the potential energy. What actually is the potential energy? The potential energy is due to the height. If we are having any of a height, we can say this one as it is having a potential energy. The energy possessed by the body due to the change in the position or the shape, it is called the potential energy. The SI unit, it is said to be the joule. We can say that the potential energy possessed by a body is the energy present in it by the virtue of its position or configuration due to its height. Stretching rubber, if you have a rubber band and you are stretching that, string, the bow, etc. A body possesses energy even when it is not in the motion. Okay, so either it is in the motion or not, it really doesn't matter. So what is the formula for this one? The value of the energy, the value of the energy will be equal to m into g into h. So we can say that we are having the mass, we are having the gravity, and we are having any of a height h. Okay, so the water stored in a dam has the potential energy due to its position, due to the height. A stone lying on the roof of a building, a stone it is on the roof of a building, has the potential energy due to its height. Wound spring of a watch has the potential energy due to the change in its shape and size. Okay, so we are having the water, it is stored, so definitely we will say this one has the potential energy. Then building has the potential, stone lying on the roof of the building, potential energy. Then the wound spring of the watch has the potential energy. After this, we have the next one, potential energy of an object at a particular height. So definitely the value of the potential energy, that one will be equal to how much? It is m into g into h. If the value of the potential energy is mgh, when the object is raised through a certain height above the ground, its energy increases. This is because the work is done on it against the gravity while it is being raised. Okay, the energy present in such an object, it is known as the gravitational potential energy. The gravitational potential energy of an object at a particular height above the ground is defined as the work done in raising any of an object to a certain height from the ground. that point against the gravity. Okay, so the work done is equal to the gain in the energy of the body. So whatever the energy body it is gaining, so it is we say this one as the net value of the potential energy. So the value of the potential energy will be equivalent to how much? It is m into g into h. Now the next one, very important one, law of conservation of energy. Law of conservation of energy says that energy can neither be created nor be destroyed, but it can be changed from one form into the another form. So a law of conservation of energy states that the energy can neither be created nor be destroyed, and it can only be transferred from one form of energy to the another form of energy. The sum of potential energy and the kinetic energy, it is same. So the value of the potential energy and the kinetic energy, it always remain constant. So we can say that this one is mgh plus half mv square, that one it is equal to constant. Now conservation of energy during the fall of a body, if any of a object it is falling, so uh, how the how it works. So dear student, a very simple thing, there are 3 points. So the total value of the 3 points which are over here, it is point B, point A and point C. Consider object of mass m which is lying at object B. It is made to fall freely from a height h. Let us think that we are having a height h, and it is made free to fall from this particular height. So at this particular point A, there will be a kinetic energy and the potential energy. Definitely at this point the value of velocity, it is equal to 0, and we are having a simple value of the height at this particular point. So we can say that the total energy will be equal to potential energy plus kinetic energy. Okay, so if we have the value of the potential energy and the kinetic energy, so we can say that the total value of the energy will be equal to kinetic energy plus potential energy. Now the value of the energy will be equal to kinetic energy and the potential energy. So we are having the value of the velocity is equal to 0, kinetic energy half mv square. So the value of velocity is equal to 0, and the potential energy, that one will be equal to how much? It is equivalent to mgh. So we will say this one as the m into g into h. So from here the value of the total energy will be equal to how much? It is equivalent to m into g into h. At point number B, as it fall, its potential energy will change into kinetic energy. When it reach at this particular point, its potential energy will be changed into kinetic energy, and if v is the velocity of the object at a given instant, the kinetic energy will be equivalent to. So at this particular point you have to find out the total value of the potential energy and the total value of the kinetic energy. Okay, so at this point when you are finding the total value of the potential energy and kinetic energy, this one is x h minus x. Okay, so at this particular point from here to here the total distance will be equal to h minus x, and from here to here the total distance which any it has traveled, that one will be given as x. So dear student, if you have to find out the total value of this one, definitely we have v square. So how much the total value, the total value of the potential energy, if you are finding this one, so this one will be equal to m into g into the total value of the potential energy, that one will be equal to m into g into h minus x. So the value of the potential energy will be equal to m into g into h minus x. Okay, so the value of the potential energy, that one will be given as the m into g into h minus x. So over here that one will be given as m into g into h minus x. Now similarly, from the Newton's third equation of motion, if we have the Newton's third equation of motion, if we are talking about the Newton's third, v square, it is equal to u square plus 2gx. So the value of u is equal to 0, so we can say that the value of v square will be equal to 2gx. So the value of the kinetic energy will be equal to half mv square. So we can write down this one as half into m into 2 into g into x. So this 2 and 2, it will get cancelled. So what is the total value which we have? It is m into g into x. So dear student, from here the value of the potential energy, that one will be equal to m into g into x, and the value of the kinetic energy will be equal to m into g into h minus x. So we have m into g into h minus x plus the value of the kinetic energy is mgx. So when you will solve this one, so this one will be equal to mgh minus mgx plus mgx. So it will get cancelled. So what is the answer? Very good, it is mgh. Okay, so the total value will be equivalent to mgh. So the total energy will be equal to m into g into h. Now at particular point number C, so at this particular point number C, as the fall of the object continues, the potential energy would decreases while the kinetic energy would increases. At this particular point the value of the potential energy will become 0. So the value of the potential energy will become 0 and the value of the kinetic energy will be equal to half mv square. So we will say that this one is half into m into v square. Okay, and what is the value of the v square from here? If you will see this one, v square will be equal to 2 into g into x at this particular point, and this one is the total height which they have from which they have covered. So you can write down this one as v square minus u square will be equal to 2 into g into the total height, that one is h. So it will get cancelled. So the v square will be equal to how much? That one will be equal to 2 into g into h. Now from here, if you have this one as 2 into g into s, so the value of the kinetic energy will be equal to half into m into v square. So that one will be equal to 2 into g into s. So 2 and 2 it will get cancelled. So we can say this one as m into g into s. So the total value will be equal to m into g into h. So from here, the total potential energy plus kinetic energy. So we can say this one as the potential energy plus kinetic energy, total energy will be equal to m into g into h. So the total energy will be equal to mgs. So dear student, you can see over here that the total value at the point number A, point number B and the point number C, if you have seen this one, that the total value, that one will be equal to the total value, that one will be equal to at point number A, at point number B and point number C, the total value will be equal to constant. Here also it is equal to constant, here also it is equal to constant. So the total value will be equal to how much? From here, from here, from here. So the total value will be equal to how much? It is from here also it is mgh, here also it is mgh, and here also it is mgh. As point number A, point number B and point number C, so total value will be equal to mgh, mgh and mgh. After that, we have the transformation of energy, a very simple question and very easy topic. It says that what are the various transformation of energy. So how energy is transferred from one form of energy into another form. So we can say that one form of energy can be converted into other form of energy, and this phenomenon is called the transformation of energy. When an object is formed, it is dropped from any of a height, its potential energy is converted into kinetic energy. If you have a cell, in case of a cell, a chemical energy, it is converting into the light energy. And simply when an object is thrown upward, the kinetic energy is converted into the potential energy. Green plant appeared their own food, they prepare their own food and stored in the form of the chemical energy by using the solar energy through the process of photosynthesis. When we throw a ball, the muscular energy which is stored in our body gets converted into the kinetic energy of the ball. The wound spring in the toy car possesses potential energy. As the spring is released, its potential energy changes into kinetic energy, due to which toy car moves. So potential energy converted into kinetic energy converted into potential energy, and similarly the different forms are there. After this, dear student, if you will see the record of this one, if you will see the record of this one, the electrical motor in a stretched bow, if you have a stretched bow, the potential energy is stored. As it is released, the potential energy of the stretched bow gets converted into the kinetic energy of the arrow, which moves in the forward direction with the large velocity. Okay, so some energy transformation are there. So the energy transformation, we have the electrical motor, electrical generator, steam engine, electric bulb, dry cell, solar cell. Electrical motor, electrical energy is converted into mechanical energy. Electric generator, the mechanical energy is converted into electrical energy. Steam engine, the heat energy is converted into kinetic energy. Electric bulb, the kinetic energy is converted into the light energy. Dry cell, the chemical energy is converted into the electrical energy. Solar cell, light energy is converted into the electrical energy. Now after this, we are having the rate of doing work. Whenever we are doing any of a work, we can say this one as the rate of doing work. So rate of doing work, it is said to be the power. Now the rate of doing work, or the rate at which the energy is transformed or used or transformed to other form, it is called the power. So when one form it is converted into another, that one is said to be a power. If work is done on it, we can say that the net value of the power, it is equivalent to net value of power, it is equal to work done upon the time taken. The unit of power, it is said to be the watt. In honor of James Watt, we express large rate of energy transform in kilowatt. So 1 watt, it is equal to 1 joule per second, and 1 kilowatt, it is equal to 1000 joule per second. Okay, so 1 kilowatt of 1000 watt. So this one is said to be the net value of the power. Okay, after this we have the next one, and it says 1 megawatt is equal to 10 raised to the power 6 watt. 1 horsepower is equal to 746 watt. After this we are having the average power. The average power, it is defined as the ratio of the total work done by the total time taken. So we can say this one as the average power. It is equal to the total energy consumed upon the total time taken. Okay, so from here the average power is defined as the ratio of the total work done to the total time taken, and an agent may perform work at the different rate at different interval of the time. In such situation, average power is considered by dividing the total energy consumed by the total time taken. So we can say over here that the average power, it is equal to the total energy consumed upon the total time taken. Okay, so after this we are having the next one, the commercial unit of the energy. The unit joule is too small to express large quantities of energy conveniently. Therefore a bigger unit of energy is used. The commercial unit of electrical energy is kilowatt hour. So when we are saying about this one as 1 kilowatt hour, or the board of the trade BOT units, so 1 kilowatt hour is equal to 1 kilowatt into hour. So what is the value of the 1 kilowatt? So the total value of the 1 kilowatt, it is equivalent to 1 kilowatt hour, it is equivalent to 1000 watt into hour is 3600 second. So what is the total value of, very important, usually it comes in the examination. So 1 kilowatt hour, it is equivalent to, when you will multiply these two, kilowatt is 1000 and the value of hour is 3600, so the value will be equal to 3.6 into 10 is to the power 6 joule. So we can say that the energy which is used in household industries and the commercial establishment is expressed in the kilowatt hour. The electrical energy used is expressed in terms of the units in our monthly bills. So 1 unit is, it is equal to 1 kilowatt hour. 1 unit, it is equal to 1 kilowatt hour. Okay, so you can find out the total value of the units from your electrical appliances, means your electrical meter and so on. Okay, thank you dear student, thank you, and please see all the topics very carefully, see the example very carefully. Thank you.